The second thing we need to go over today is average value of a function, and it's just what it sounds like. We're trying to find the average. So I've got a picture drawn here of a function. We'll just say this is the ticket sales of the Renaissance Festival for 4 weeks. And if we wanted to know the average value of the, I guess you could call it the ticket sales per week, then how would we do it? So this would be the rate at which they sell tickets, and we're trying to find the average value. So just think about the way you normally do an average. When you normally do an average, you add everything up and you divide by the amount you have. So if it's 10 numbers, you add up all the 10 numbers, you divide by 10. So you've got to do the same two things for a function. Well, to add up everything, that means you need to add up all of the area under the curve, which we now know is found by using the first fundamental theorem. So we would just set up an integral, in this case from 1 to 4, of our function. Excuse me, 0 to 4. 0 to 4. And that would add up all of it. So that would give us the total ticket sales. But what we're wanting to know is not the total, we're wanting to know the average ticket sales. So we need to then divide by the total amount we have. Well, if we're going from 0 to 4, what would make sense? What would we divide by? 4. Because that's the length of our interval. We're going from 0 to 4. So this is how you find average value. There's two ways you can write the formula. You can either write it integral from a to b of f of x dx over b minus a, which honestly I think intuitively probably makes a little more sense because it helps you see that you're adding up everything using the integral, then dividing by the length of your interval, which is the amount you have. You can also see it written this way, and they're just pulling the b minus a out front because that will just be a number since it's a distance of the interval. So that's another way to write it. So these right here are the average value formulas. And you can use either one. They're both equally good. But this is one you need to commit to memory because it's just a normal integral and then you divide by the length of the interval. Okay, so let's just do one example. This should be pretty straightforward. Okay, so this one says find the average value of f of x equals 3x squared minus 2x on the interval 1 to 4. Okay, so just remember the equation we just used. I'll just rewrite it right here. If you prefer the other form of it, that would be fine. There's no difference. But our b is going to be 4 and our a is going to be 1. So 1 over 4 minus 1 times the integral from 1 to 4, and then we plug in our function, 3x squared minus 2x dx. Okay, so really, this is exactly the same as what we were doing with the first fundamental theorem. The only difference is this constant out front. So we have 1/3 out front, integral from 1 to 4, 3x squared minus 2x. Now we should be ready for the antiderivative. So 1/3 times x cubed minus x squared from 1 to 4. Then we plug in the top number, so 1/3 times 4 cubed minus 4 squared minus 1 cubed minus 1 squared. So 1/3 times 64 minus 16 minus, well, that's just going to be 0. 1 cubed minus 1 squared, 1 minus 1. Alright, so we get 1/3 times 64 minus 16. Let's see, that's going to be 48. 1/3 of 48 is 16. So the average value of that function is 16. Alright, so hopefully that makes sense to you. That's the average value of the function. And now we're ready to practice. So the homework for this night was page 286, numbers 75 through 80, and then 82 through 92 even. And those are all on the second fundamental theorem. And then also on page 285, I'd like you to do number 49 through 52. Those are 4 average value problems.